Okay, the first thing that you need to do to determine what you want to do is decide whether you're doing this just to power a certain fraction of the electricity you need for your home, or you want to maximize, like you've got a certain number of square feet, you want to cover the whole thing with panels. So you assess how much you actually need. And you can do that by doing the energy audit of your home, doing a plug load analysis where you're actually picking out ways to cut your electric costs down to as low as possible. Then you specify the equipment. Most of the installers should give you $1 per watt peak. Do you ever give $1 per kilowatt hour calculations? No. You can tell them you want it, and maybe he'll do it for you. I would recommend at least thinking about that a little bit. One, it will make it easier to compare to current grid electricity, but also it takes into account the idiosyncrasies of certain types of equipment. And so, at the university, we've got our heads inside an egg or whatever, and so we're like very 1% difference on something makes a big difference to us. And so things like which inverter you choose, even though they're all rated for the same power levels, they have different controls in them. And so some of them will, for instance, cut off when you get a little bit too much power if you sized it wrong. And so for an extremely cold day, your inverter turns off. It might be brilliantly sunny, it's brilliantly cold, your inverter turns out because it's making too much power. And so if you're losing days like that in the middle of the winter, that's a problem, and you're not going to get the same performance that you expect. So you want to look in or encourage installers to look into the nitty-gritty details. Now, of course, they've already done a bunch of systems, so they'll probably give you a good design right off the bat. I would strongly encourage you to get multiple quotes the same way that you would do for everything else, and have them go through the entire process with you. When you guys do site, how do you do the site characterization? You use like fisheye, or how do you do it? Okay. Yeah. So you get a very good estimation for how much shading you're going to get from neighbors' trees, telephone poles, and that kind of thing, and how that will affect the performance of your system. In terms of follow-up and maintenance, the good news is there's almost zero. Some of the larger, like if you're building a 10 megawatt solar farm, they're going to calculate in some maintenance costs, but for the typical homeowner, you don't really need to do anything for the panels. The rain will clean them off. They don't do anything. They just sit there and make you electricity. So you're okay to just let them be. I don't think there's zero maintenance unless something goes wrong. And usually, if something were to go wrong, that would be your inverter, and those are usually under warranty, so you just call the installer back in and they trade out the piece. But like you were saying, you've never even had a problem, so there's zero maintenance. I think I can say that.
How much cost-wise does it cost to install solar in an average home? How much?
So it depends how much you want. I was going to use $10 a watt, and I found out it's a little bit more expensive depending upon which contractor you go to. But if we use $10 a watt, to power the average gluttonous energy home, you maybe need 5 kilowatts. And so 5,000 times 10 is 50 grand. To do a more energy miserly home to power the whole thing, provide enough electricity, might be half that. It's around 25,000. And if you look at the economics of it and fold it into your mortgage, it makes sense. If this is something you're just upfront doing, that's a pretty big investment for most people to pay for electricity. I see a lot of heads nodding. So this is a case study for a system that was actually installed by Rob Miller, who's a big, huge switch proponent. And he is responsible for the wind farm, but also is now getting into the solar business. And so he thought he'd do his own house to see what it's like. His costs were about $10,000 per kilowatt or $10 a watt. You need a south-facing roof. He got the standard offer contract. He went through the online application. Went through Kingston to get everything attached, and he used a Xantrax inverter. And so this is a picture of him and his family and their little system on the back of their house. It's only 1.36 kilowatts, so it doesn't cover all of the home's needs, but about 40% or so. It's a nice, cute little system, and he got into the technology with this. And so the good people at Quantum Renewable Energy and Kennedy Electric helped him install it. I apologize for the text getting skewered again. And this is what the inside electrical panels and everything look like. And so you've got your inverter, and then these are the meters on the outside, and I think he must have zeroed it when they installed it, so he's able to calculate the exact solar fraction for his home being provided by just those few panels. And so that was, in no way try to maximize surface area covered with solar. And so for this region, he just lives downtown Kingston, about 1,600 to 1,700 kilowatt hours per year for the system that was 1.36 kilowatts. Okay, so now the economics of it. At $10 a watt, the two systems that have sort of been publicly made available in Kingston are the school system, which had a 16-year payback, and Rob's system, which had an 18-year payback. And so when you hear big numbers like that, it's tempting to just run away. But I strongly encourage everybody, no matter what type of renovation you're considering, to go one step further and do the ROI calculation, because it actually is not so bad. When you look at after-tax ROI for investments that you make in your stock market portfolio, in your retirement, in what you're paying on your mortgage, things like solar cells that have 25 to 30-year lifetimes, even with 18-year paybacks, are not so bad. So this is something I'm actually doing for the university, where we're, of course, trying to save money along with everybody else, and how we're doing energy retrofits there. And so what I've done here is I've graphed the payback time of an investment, it doesn't matter what it is, solar cell, wind turbine, new installation in the roof, whatever, versus the lifetime of the device. And if you do that, and I'll be happy to share how to do this mathematically with everybody. I have papers we can send out, we can post them on the wiki or whatever. You could graph a given rate of return as a function of payback time and lifetime. And I've put up 2.5%, 3%, and 4%. And the 2.5% and 4% are important for Queens. 2.5% is what Queens expects to return on its endowment, and 4% is one of our best years. And that's not including this last year with all hell broke loose. So if I can find investments for Queens that beat 2.5% or 4%, they're interested. And they're interested in making that retrofit because it just makes economical sense. And so the way that you use graphs like this is you get a graph with all the percentages on it. I've cut most of them off. I've only kept on the little ones, the 2.5, 3, and 4. And you take your 18 years for your payback time, which is easy to calculate. The red screen will spit that right out for you. And your payback time, you connect the dots. And so here, I can guarantee Queens, with the least economical system that has been installed and made publicly available in Kingston for solar cells, that we will get a better rate of return than they can on their endowment, that they have been historically. And that's using the 25-year warranty lifetime. But let's say that you get panels through the 30-year warranty lifetime. Then you just move up here, and you're almost at their best year. You're almost at their 4% year. The other system, the school system that had a 16-year payback at 25 years, happens to smack right on their 4%. And so one of the projects we're involved with at Queens is looking at getting an awful lot of panels and covering every flat roof surface we've got, because it just makes economical sense. And if we do that, we're not buying panels for $7 a watt. We're buying them down for the American rates that I'm used to, under hopefully $5 a watt. And so that is imminent. There's a student working right now on cataloging all the surface areas on campus that are available, and that should help all of us out, myself included, for looking at doing it in our own homes, because it'll give the scale that you guys need to drop your prices just a smidgen. At the same time, there's two other forces taking place. So you have scale finally reaching the area. You have the solar cell market as a whole dropping panel costs. And so towards the end of this year and into the next year, for sure, the panels will be cheaper than they are now. And then we also have the standard offer program hopefully being slightly more generous.